Lesson 15.17, finding area of quadrilaterals from coordinates. They'll want you to plot the points and then find the area yourself. So we're finding the area of a rectangle. Remember, area of a rectangle is just length times a width. So if this rectangle would have been turned so that we would have had vertical and horizontal lines, no problem. But because it's slanted and these lines are slanted, we have to use the distance formula of the coordinates or just make some right triangles here so that we can do Pythagorean theorem. So to find this distance, I need to know the two legs of my triangle. So from x to w, if this is at -1, this is 9, this must be a distance of 10. If this is at -7 and this is at -1, this must be a distance of 6. And you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay, and then I would do 6 squared plus 10 squared equals c squared, and just do it on my calculator. And I already know that 6 squared is 36 plus 10 squared is 100. That's going to be 136. The square root of that gives me a decimal. A decimal. I would probably just leave it the square root of 136. Not even simplify it yet. So there's one of the dimensions. Now let's find the shorter side of the rectangle by making a triangle here and here. So this is a 1, 2, 3, and this is a 1, 2, 3, 4, 5. So you could do your negatives. You don't even need to. We just need the measurements of the legs. So the negatives don't matter. We'll have a 3 squared plus a 5 squared equals c squared. It'd be 34. So we'll get a square root of 34. Now we know that we're just multiplying those. And so if I have square root of 136 times square root of 34, I get simply 68. So to me, it's a lot faster to do it on my calculator than try to break these up and then know the rules of multiplying radicals. So it'd be 68 square units. All right, number 2, we have what is known as a parallelogram. Parallelogram area is basically just like a rectangle, but instead of calling it a length and a width, they call it base times height, meaning it's one of the dimensions. Let's say I call this my base. My height is not the slanted side, it's going to have to be perpendicular. So I have to have a right angle here so that I know the actual height from one base to the other, which looks like 1, 2, 3, 4, 5, 6, 7. And I would call that my height. So my base was 1, 2, 3, 4. So this is actually the easiest one because I'm simply taking 4 times 7, base times height. And that would give me an area of 28. So I like the parallelograms the best. Last one is the rhombus, which is tricky because you have to remember that a rhombus has nothing to do with the side lengths. It's all about the diagonals. So the area of a rhombus is 1/2 times diagonal 1 times diagonal 2. So we need to find from N to L and from M to K. And we'll multiply those together and then take half of that. So to find N to L, I'm going to make a right triangle right here. So that looks like up 1, 2, 3, 4, 1, 2. So it'll be 4 squared plus 2 squared equals c squared. That would be what, 16 plus 4, that would be 20. Square root of 20 is one length. And then from M to K, we've got a really big slope triangle here. Looks like this is a distance of 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3. Well, I can just go -9 here would be 9. Plus 7 would be 16. So it'll be 8 squared plus 16 squared equals c squared. It'd be the square root of 320. Again, I am not going to try to simplify these. I'm just going to plug them in. And hopefully they turn out to be something good. I didn't mean to put 330, 320. So 1/2 is really just 0.5 times square root of 20 times square root of 320. And that just gives me an area of 40. And that's it.